So on this one, we take our 3 and do what? Divide by 2, and then we square it. So now I have x squared plus 3x, and then plus what? 9/4. All right, did I add 9/4? I did, so I'm going to subtract 9/4. All right, so now I end up having f of x is equal to x, and then what? 3 over 2 is 3 over 2. So now I have plus 3 over 2, quantity squared, and then minus 2. All right, so now my vertex is 3/2. Oh, not 3/2, but what? Negative 3/2. So I get negative 3/2, comma, negative 2. All right, so this is where I like to start sketching. So what quadrant am I in? I'm in the third quadrant, so I'm somewhere down here. And then which way is it going? Is it going up or down? It's going up or down? It's going up. Why is it going up? Because my A is positive. All right, because my A is positive. And once I have that, I know my axis of symmetry pretty easy. So my axis of symmetry is x equals negative 3/2. All right, and the hard part about this one's actually going to be finding the x intercepts. So when we solve for x intercepts, we substitute in 0 for the y value. All right, and so when we begin to solve it, what do I need to do first? I need to add 2. So now I have 2 is equal to the quantity x plus 3/2 squared. And then, what's my next step? I'm going to do what? I square root it. So when I square root, I need a what? A plus or a minus going on. And so then I end up having x plus 3/2 is equal to square root 2, and x plus 3/2 is equal to negative square root 2. And my last step would be to do what? Subtract 3/2. So my ordered pair would be negative 3/2 plus square root 2 comma 0. And then I'd end up having negative 3/2 minus square root 2 comma 0. All right, because x intercepts are ordered pairs, not lines. Okay. Max is going to read for us. Go.
A baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to the ground. The path of the baseball is given by the function f of x equals negative 0.0032
That.
x to the second plus 3, where f of x is the height of the baseball in feet and x is the horizontal distance from home plate in feet. What is the maximum height reached by the baseball?
All right, fantastic. So, if we're finding a maximum height reached by the baseball, okay, a maximum, that means it's going to be at its what? It's a V word. It's vertex. Now, what we've been doing the last couple days is we've been putting it in standard form or vertex form. However, what would we have to do to this equation to start putting it in standard or vertex form? What would I have to factor out? A negative 0.0032. That's what we'd have to factor out. True? So there's got to be another way to tamp it. That sounds awful. All right, which it would be. All right, so what we're going to actually do is we're actually going to go back to using what we did in Algebra 1. So we used this in Algebra 1. We found our vertex as negative b over 2a, comma, f of negative b over 2a when it's given in quadratic function form. All right, so I'd end up with x is equal to, well, what's my b? 1. So now I'm going to change it to negative 1 over 2 times, what's my a? Negative 0.0032. All right, and then I'd bust out my handy dandy calculator, unless you guys can do that in your head. And so we end up getting 156.25 feet. However, what did we just solve for? The x or the y? We solved for the x. What's it ask for? What is the maximum height reached by the baseball? How do I get to my height now? What do? I substitute that back in for x. So now I end up finding f of 156.25. And so we'd use our handy dandy calculator. 81.125 feet. All right, so what that tells me is that at 156 feet over from hitting the baseball, then it goes up at 81.125 feet. All right, so that's what it's actually doing. That's another way to find the vertex without putting it in vertex form. All right, that's actually what you guys did in Algebra 1. All right, so now we're on to 2.2, polynomials of higher degrees. All right. And to be a polynomial function, it means it has smooth curves. It's also called well-behaved functions. All right, they're not naughty. All right, so they're smooth curves, and they're continuous. All right, what continuous means is that in layman's terms, you can draw it without lifting your pencil. All right, so that's what we're going to be talking about in this section. All right, so polynomials, nice smooth curves, so I can draw it without lifting my pencil. In part B, this is discontinuous. You see how it's discontinuous? Guess what kind of discontinuity it's called? It's called a jump. Doesn't that make sense? See how it's a jump? All right. This is also not a polynomial because it has a sharp turn. Do you see how it's not smooth? All right. That's a sharp turn, so that's also not a polynomial. This one, nice smooth, baby butt. All right. Smooth curve. All right. All right, this one. Okay, I don't do this as well as Papa Francis does. I'm telling you right now, this is one thing that Francie is hilarious at doing. All right, so this is called the leading coefficient test. All right, so what your highest power is, it tells you where it starts and where it ends. For instance, if my highest power is odd, so like x to the 5th, x to the 7th, something like that. If my highest power is odd and it's positive, it's going to start down at negative infinity, because in America we read left to right, true? So we're always going left to right. It's going to start at negative infinity, and where's it going to end? Positive infinity. All right? And then if we have an odd power, okay, so like, but it's a negative coefficient, so like a negative 2x to the 7th, something like that. You see how it's negative and it's an odd power? This one would start at infinity and end at negative infinity. Do you remember Francie going like this? Remember that? Okay, I can't move like that big guy. All right, I'm telling you, if you need tutored on this, he's actually better than me on this one. All right, he really is. Not gonna give him too much, but this one he is. All right, he's hilarious. All right. On even powers, they start and end in the same direction. For instance, if I have a positive even, like I don't know, a 2x to the 4th or something like that. Positive, true? And it's an even power. So they're going to start up and end up. They're going to start at infinity and end at infinity. All right? However, if it's a negative even power, like let's say negative 3x squared or something like that. You see it's a negative coefficient, but it's an even power. That means it's going to start at negative infinity and also end at negative infinity. All right? Now, when you look up answers on CalcChat, I hate the way that they say it. Okay, I disagree with Ron on this one. They're going to say it falls left and falls to the right. I don't agree with that. I say it starts down and ends down. Okay? Because in America, or anytime you read a graph, you always go from what? Left to right. So I hate their notation on this. Okay? So you're starting at negative infinity and you're ending at negative infinity. All right, pretty good? Go. So this first curve. Oh, first of all, I got to tell you about how they hug graphs, and this is more of a non-rigid thing. But you guys should know it. If I have an x squared and x to the 4th, they're both positive evens, right? They're both positive evens. However, what you should notice here is an x squared is just kind of going to like touch and then go back up. However, an x to the 4th or even an x to the 6th or something, it's going to spend more time at where it's going to touch. All right, it's going to hug it a little bit longer, and then it's going to go back up. All right, am I truly going to test this? I'm not, okay? However, you should kind of know that. All right, so if it were like an x to the 6th, guess what would happen? hugs it even longer. If it's an x to the 10th, guess what happens? It's a long embrace. All right? All right? I see that. Well, I don't see it as much because of COVID now, but before, you guys are gross in the hallways. All right. So the same thing deals with odd functions. So let's look at this first one. I have negative x to the 5th. I'm going to sketch a graph of negative x to the 5th. Well, where does this guy start? He's a negative odd power. Where does he start? He starts where? Where? Positive infinity. He starts up here. True? Where's he going to end? He's going to end at negative infinity. True? Where is he going to cross? Where's he going to cross the x-axis? If I set this equal to 0, where is he going to cross? At 0. So he's going to cross right there. All right? And so there is what a negative x to the 5th does. Pretty simple. All right, let's look at this next one. I have the quantity of x plus 1 to the 4th power. Where's it going to start? It's going to start up. Where's it going to end? It's going to end up. True? Where is it going to touch my x-axis? Negative 1. All right? It's going to touch at negative 1. And so there would be my sketch. Pretty cool? All right, let's keep. So this first one I have is negative x cubed plus 4x. We're going to put some things together now. Where does it end? Or where does it start, I mean? Where does it start? It starts up, true? Where does it end? It ends down. Agreed? Now, I'm going to solve for its zeros, or its X intercepts. So I'm going to set this thing equal to 0. But before I do anything more, how could I play with this negative x cubed plus 4x? What could I take out? I can factor out an x. Let's factor out an x. So now I end up having, can I go further than that? I want to do a negative x, if that's cool with you. And then I'd be left with what? X squared minus 4. All right, you could get there if you just factor out an x, but it might be a little bit more taxing for you. All right. Can you do anything more? Yeah, what can you do more? F it up again. So what does it F up to now? X plus 2, x minus 2. All right, so after we F'd it up, now what are my zeros? 0, 0, and? Negative 2, 0, and? 2, 0. All right, so we have a dot there, and then we have a dot here, and then we have a dot there. Good, good. And so now it's going to go, now we need to connect them. So we go whoop, 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 and then we're done. All right, pretty good. All right, let's do the next one. I have x to the 4th minus 5x squared plus 4. What this is a hidden quadratic. All right. Those who had me in Algebra 2 last year are very accustomed to these. Have you guys done hidden quadratics very much? No? A little bit maybe? All right. So think of this as like x squared squared minus 5 times x squared to the 1st and then plus 4. Okay, that's kind of the way you should think of it. So it's like instead of x, it's now x squared. Are you following me? All right, so what would this F up to? I got to get to a positive 4 and a negative 5. So what would that F up to? X squared, what? Minus 4, x squared minus 1. All right, and then what can you do? Can you do anything more? You can factor it again. So this would be what? X plus 2, x minus 2. And then this would be x minus 1 and x plus 1. So then when I put the zero product property on it, so then I'd have zeros at negative 2, 0, and 2, 0, and 1, 0, and negative 1, 0. All right, so I got a little dot there, a little dot there, a little dot there, and a little dot there. Now, it is a positive even power. So what's its end behavior going on? Where's it start? Starts up. Where's it end? It ends up too. All right, and then we go whoop, 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 whoop. All right. Pretty good? Good with that, Max? All right, let's do the next one. So now I have x to the 5th minus x. Josiah, where's this bad boy start? And he starts down. Where's he end? He ends up. There you go. All right, what can we do with this guy? Yeah. We can factor it. What can we factor out? Just an x, just an x. So now I'm left with x to the 4th minus 1. Again, this is kind of a hidden quadratic. I would think of this as x squared squared minus 1. Are you following me? All right. So what would that factor to? X squared minus 1, and then x squared plus 1. All right. Think of it as x squared squared instead of x to the 4th. All right. And then, can we go even further? Sure can. We can do what? X minus 1, x plus 1. And then, can I factor this x squared plus 1 thing? Not in real life, anyway. Okay, you could do imaginaries, but we're not doing that yet. All right, yet. So now, I could use the zero product property, so what would I get? 0, 0, and 1, 0, and negative 1, 0. All right, so I got a little dot there, little dot there, and a little dot there, and then let's connect them all. And there we go. All right, pretty good. All right, that's all I can. And there you go.